Well, good afternoon, everyone. I want to welcome you to the latest edition in the ongoing Wire-sponsored webinar series that focuses on different innovative technologies that we are using in the transmission space these days. For today's presentation, I'm very pleased to have power engineers here to talk about ballistic threat analysis. And it's particularly interesting to see how that plays into the context of providing protection for our infrastructure against potential physical threats. I have a presentation that's going to be running for probably about 30 minutes, and then we'll have the opportunity for question and answer from all of the attendees. So I want to invite you to submit any questions you have through the question function, and that appears on the right hand of your screen. Just click that on, type in your question, and then we will work it into our presenters after they get done with their set presentation. So start thinking about those questions. They're anxious and eager to hear what people are interested in finding more about with respect to this ballistic threat analysis approach that we've got. So very happy to have some great people here today from Power Engineers. We've got Chris Ott, we've got Jason Paff, and we have Margaret Neves, who's going to lead us off with the introductions for this session. And I'm going to go ahead and turn it over to them, and we'll see what the presentation is that they have for us today, and then we'll move to Q&A after that. So Margaret, thank you very much for doing this. We appreciate your taking the time to educate us all on this interesting approach, and we're anxious to hear more.
Yeah, well, thank you, Larry, and thanks to Wires for this webinar series. It's really been a great platform for knowledge sharing and just demonstrating new technologies to support the industry. So my name is Margaret Neves. I'm the Business Development Director for Power Engineers. Power is a multi-service engineering and environmental consulting firm. We are headquartered in Haley, Idaho, and we have offices across the US, approximately 50 plus at the moment, to be close to the clients that we serve. So as consultants, we watch trends and focus our efforts really on how to support the needs of the industry and our clients while providing efficiencies where possible. So one such need became clear about 10 years ago, which you'll hear about soon, with attacks on physical infrastructure. Through our innovative technology group and internal subject matter experts that we have here today, we developed and continue to refine our ballistics line of sight analysis tool, which accomplishes two things: securing infrastructure while reducing costs where possible. So our Chief Innovation Officer, Jason Paff, has been instrumental in developing cutting edge technologies for power for over a decade. Jason is that kind of expert that all organizations need. He's got that if you can think it, we can build it mentality. So I'm going to turn it over to you now, Jason, and get the conversation started.
Awesome. All right. Thanks, Margaret. Like Margaret said, my name is Jason Paff. I'm the Chief Innovation Officer. And just to give you a little background about how we even developed a piece of software around physical security, my role as Chief Innovation Officer is really to take a look at the challenges we have in our industry, like physical security, doing the assessments for those, and trying to find solutions. And a lot of our solutions today look like technology or software. But this specific software that we developed is around digital twins, 3D modeling, animation, which is really something I'm passionate about. My background's landscape architect, visual analyst way back in the day. I have my own company focused on 3D modeling, animation, and game engine technology. So it's really this type of technology became ready for us to be able to evaluate physical threats using digital twins, and we'll show you that in a minute. But with every innovation that anyone works on in a company, you have to have a pilot, right? You have to pilot it, you have to make sure it works. So to that end, we approached Portland General Electric back in 2019, I believe, with this kind of crazy idea to use software to look at real-time threats. And that's where I met Chris. He was actually started out as a client over at Portland General. So with that, I want to hand it over to Chris to kind of lead us and kick us off into what this thing is. So, all right, Chris, it's all yours.
Great. Thanks, Jason. Appreciate it. Yeah, just to give a little bit of context and my background. So I got into the security industry in the late 90s when I joined the United States Marine Corps. My background in the Marine Corps was power generation and distribution. I eventually ended up working with a unit to where we identified critical utility targets in foreign nation states. This would have been right around the kickoff of the Iraq War. So my mission was to assist in figuring out how to neutralize utility targets, given whatever military assets we had available at the time. Left the military, got into the civilian sector after getting my electronic engineering degree, and I spent the next 14 years designing and implementing industrial and commercial security systems for corporations like healthcare, Department of Corrections, and ultimately power utilities facilities. So after doing that for about 14 years, got hired on at Portland General Electric and helped build and develop their in-house engineering and protection group for their locations. That was all underneath the corporate security umbrella. And so really I became the CIP-14 expert shortly after the incident that happened. We'll talk about that here in a little bit in 2013. And they figured that because of my background on the military side, my background in the security systems and protection side, it was a good fit.
Yeah. So one of the things I tease, hold on, I got to throw this in. With Chris, one of the things that's unique about him is, and I always tease, to stop a bad actor, you have to think like a bad actor. And his experience in the military, thinking like a bad actor, has certainly helped us develop some new and innovative and unique solutions for this thing. So anyway, thanks, Chris, for thinking like a bad actor for us. This is good.
Yeah, no problem. Thanks, Jason. So real quick, many people in the industry are familiar with the Metcalf attack. So we'll just touch on that momentarily. All right, so back in 2013, there was a ballistics attack in conjunction with the severing of communication lines at a substation in California. About 120 shots were fired and $15 million worth of damage was done. So within about a year after that is when the CIP-14 standard came out, because the federal government saw this as being as a concern from cascading catastrophic events as it pertained to bulk electric system and transmission sites. So real quick, we'll talk about some physical security trends that we're seeing in the industry around this particular topic. There are about 1,700 physical security incidents reported to the EISAC in 2022. That's an increase of about 10.5% from the previous year. We're seeing security incidents involving the grid. It's tampering, vandalism, arson, ballistic damage. So that's one of the areas that we're focusing on, right? So in case anybody doesn't know about what the EISAC is, it was created in 1999 as a division of NERC. It's a location where only utilities can attend and be members of, and they can listen in, read, and share any physical security or cybersecurity related events that's happening around our grid system. It's a really good location for folks to be as involved as they want, or just sit back and use it to pull data. So
you said free for utilities, right?
Yes, yeah. That's correct. Yeah. So to continue on security trends, right? So it's about 200% increase in 2023 from that 2013 incident that happened in Metcalf, right? So we're seeing a lot of copycats, similar types of occurrences happening around the globe, and primarily in the US. So that's about 50% nationwide from 2022 to 23. And what we're seeing and recommending to a lot of utilities is to create a tiered scale of criticality outside of the NERC CIP requirements. So figure out what your most important clients and users are of your substations and locations. Put those at the top of the tier. It might be healthcare, it might be DoD, could be law enforcement, could be big tech, right? So one of the things that we take a look at is ground-field and brownfield related security standards. Building a standard to help you create a better security stance. And another one of the things that we like to see is, and are seeing in the industry, is companies are building a DBT, or Design Basic Threat program. So that way they can take a look at the environment and the communities around where these locations are and act accordingly. And the last thing that we're seeing in physical security trends from utilities is an increase in information gathering, whether it be a relationship with local law enforcement or using third-party companies to gather data around their companies. Data miners, ZeroFox, Foresight, just a couple of examples. We at Power Engineers are product agnostic, so we don't support any one particular brand or manufacturer. But when we see good things out there, we take a look at it and give clients options. So.
Hey, Chris, just real quick.
Yeah, sure.
One of the things I think you've said in the past that they might want to hear is, why are we seeing trends increase? I mean,
good question. Unfortunately, with the unsettling environment that's going all around the U.S. and around the globe, like I said, we're seeing a lot of copycat attacks, extremists on the far right and the far left. We have the Earth First movement they're not a fan of technology, and so they want to take us back to, the pre-biblical days, apparently. So
yeah, that's crazy. All right, well, thank you.
Yeah, sure. So we'll just touch momentarily on some more recent attacks to give us additional context and some points of data from those previous percentage marks that I mentioned. Right. So over in North Carolina, just a couple years ago, there was an incident where some transformers were shot up, some damaged gates, and about 45,000 people without power. Over in the Pacific Northwest, one region in the Tacoma, Seattle area, there were 4 substations attacked in Washington. That particular occurrence was done by some bad actors who had the intent of robbing a convenience store. So what they did is they drove around Christmas Eve and Christmas Day in the early hours when it was dark, took out some transformers in the attempt to knock out power to the business so they could rob it. And then right around that same time frame, there were 3 occurrences in Oregon.
Yeah, there was one more. I live in the Pacific Northwest, and there was one more in Idaho. I'm in Idaho. That occurred here several months ago, 3 or 4 months ago. Yeah, in Idaho. So yeah, that was kind of near and dear to my heart. Yeah. I want to talk about this last one though in Maryland. One of the things that's, we do a lot of system planning, and we evaluate risk associated in system planning. That's how we determine how we grow, manage, and maintain our systems. But in Maryland, there was something interesting that happened. There was no specific attack, but there was a conspiracy to attack multiple substations. And if they would have been able to carry this out, it actually would have left about 1 million people without power. But what was interesting about this specific one in Maryland is it wasn't targeted just to SIP facilities. It was lower voltage facilities, but there was multiple ones that were going to take out that would have caused a significant amount of damage. And I know that NERC came out here last year and was evaluating whether they should look at lower voltages, include that into the SIP 14 program. So it'll be interesting to see where this goes in the future.
Yeah. So the reason why we mention this is, it's a trend that's happening coast to coast, border to border, right? So it doesn't seem like it's any one region. So that rolls us into our ballistic threat study. Jason?
Yeah, all right, let me tell you how this got started. So it actually got started through an engineering request. We're doing some work over in the East Coast for a client that was building a new substation. And they wanted to know, were they overbuilding, were they underbuilding, because a lot of the issues that they were facing was off-site threat, specifically from like ballistic threat or gunfire or whatever. So they wanted to know if their critical infrastructure, if they could see it. So we started from a digital twin perspective and developing a 3D model, their greenfield site, went out, in this case, about 1 mile to identify all the potential line of sight lanes where people could shoot from. And that's where it started, was engineering. And what we found in talking to a lot of engineers and some utilities is that security almost seems to be an afterthought. A lot of times you'll do your general arrangement and then you'll go through and start putting security on top of that. But we feel that engineering and security should go hand in hand, more of a synergistic approach. So that's what we're trying to do, is build more of a culture of safety, build a culture of security in the engineering solutions we provide. So that's really where it started, was born out of an engineering request.
Yeah. Yeah, and one thing to mention too, that terrain plays a large role in these surveys and these studies, because the world isn't two-dimensional. So.
Yep.
So Jason.
Yeah, again, just, I think working hand in hand between the engineering and the security teams is really, really important. I've actually talked to a few security folks at utilities, and I believe that they should be brought in at the front end of a project, at the siting of a project. Like Chris was mentioning about terrain, elevations, being located next to a water tower, top of a building. These are things that we've encountered when we've been doing these analysis, is that if you could site it or be part of the siting process as a physical security specialist and help the engineering team site it, you can reduce a lot of the physical security issues that you might face. So again, just reiterate that synergy you should have with your, all the way from planning to engineering to operations and maintenance, which leads us into this tool we developed. It's still version 1. We're working on version 2 right now, but we're happy to show you where we're at, the progress we've made. It's been used quite extensively over the last couple of years. So yeah, so we'll talk about Power Guardian's the name of it today. Again, just a lot of utilities, how they approach physical security is this, I don't call it brute force, but programmatic approach, where they'll just, build a standard, put a 15, 20, 25-foot wall in some cases around a substation. And, putting on my visual analyst hat back in the day, sometimes just putting a standard vanilla wall around something, specifically like an urban environment, doesn't always work. Or when we did our first substation project, they were wondering, is there a way to reduce some of the amount of build on here to save a little bit of money? Although that's not the reason we do it. We did find that first one actually saved them about $1 million in just construction costs. So
So real quick before I jump to the next slide, one thing to take note of in this picture, this giant water tower, that is significantly taller than this wall. So if a bad actor were to get up there, they can see right inside.
Yeah. So that was our challenge on the first one. Again, I just want to reiterate, we don't do these just to save money. We do these to make sure that the assets are protected. But a lot of times we can save money by reducing overall construction build, but it's really build what is needed is important.
Perfect. Yeah. Thanks, Jason. Yeah. So once again, Jason had mentioned the brute force approach to protecting substations. A lot of clients are building a ballistic wall, in some cases all the way around the perimeter, like you saw in the previous slide. Transformer ballistic rated barriers closer towards the transformer, and in some particular cases, when nothing else is going to be sufficient, armor on the actual on the actual transformer itself. What we found is when you bring those protections closer into the asset that you want to protect, they don't need to be as long, as tall in some cases, or as wide. So how does this tool work? So in this slide right here, we had a client reach out to us just as an example, where they were proposing on putting a substation, and they gave us this location. So what you're seeing in this depiction is the blue dotted line indicates the proposed fence line where the substation was going to go, and the area around it on the outside in black was the area of concern that they wanted to see if somebody were to get within that black defined border, would they be able to attack the substation? Which brings us to the next slide. So what we did is we were able to model what a substation would look like in this particular location. What you're seeing there in the highlighted green area on this representation is a proposed change in foliage. So what we know in the industry is that if you can screen the object and you can't see it, it makes it a whole lot harder to attack it and to damage it. Now, that's not to say that that's ballistic rated foliage. Everybody knows that trees and bushes can be walked through and cut down, but it just was one thing to think about. And then the image over here to your right is what those components could potentially look like in that footprint of that model. That brings us to this next slide real quick. So what we did is we used BIM technology. In this particular case, this is a greenfield sub that doesn't exist, and we're able to create in augmented reality what a substation would look like in very, very finite detail, right? And you can tour the whole entire property, take a look at components, do an inspection, Once again, this is a greenfield example, but we can do this brownfield as well. So, if you ask me, it looks very real.
Yeah, I want to pause here for just a second, because what is critical to do in a ballistic threat analysis is accuracy. In fact, you can go to the next slide, Chris.
Yeah.
You have to have your components accurate, because all the equipment inside of your substation, your critical infrastructure, actually serve to either be visible or screen things from being visible. So you have to make sure it's accurate. And I've used visualization technologies and geospatial solutions. I've done visual analysis for years, but it always lacked that accuracy. Now, the reason we can do this now, and why this technology exists, is that we've been able to combine the ability to capture information quickly, and we call that reality capture, and we capture that as a digital twin. And so you have to remember, we have to go all the way out, not just including the substation, all the way out to what the utility deems to be the maximum distance a shooter could get a shot off. And in some cases, they want us to go out a mile. So we got to create an accurate representation of the facility out to a mile radius of these substations. And this is where our drone experience. I'm a certified drone pilot, so I've been studying this for since 2014. But with drone, LiDAR, BIM technology, reality capture technology, we can create digital twins all the way out to a mile and beyond of these critical facilities at a really high accurate representation of the facility. That is the key to bring it into the game engine technology that we'll show you here in a second. But that's what has been unlocked in the last 3 or 4 years.
Yeah, thanks, Jason. So in this next slide that I'm going to show you before I click on it was a video of a live workshop that we did with a client, and it was a brownfield site. And so what I'm going to do is I'm going to talk through this process since there's no audio on how we actually did this.
Hey, Chris, before you start, I did want to mention this is the digital twin that we captured, and it took us about an hour and a half to capture with drone, that in the study area, and then a couple days to come back and process that information to be able to drop into the reality model. And this is an old model, but one that we can show. So. Yeah,
perfect. So what we're doing here is we had placed and are in the process of placing in this video photo illuminator replication on the top of the bushings in this particular case. So we were concerned on what can see everything from the top of the bushing of this particular transformer and lower. So there's one illuminator on that bushing at the top of that transformer. We're going to place 2 more.
Yeah. The cool thing about this was done in a workshop. And it was done in a workshop with the engineers, system planners, security specialist, and the operations manager and power engineers. So this was done during COVID. That's why we had to do these virtual workshops. And so what you're seeing here is that screen recording of that virtual workshop.
Yeah. So everything that's highlighted in red in this video can see that asset. You can see up here in this field, there are some areas that are highlighted in red. That's because the terrain is slightly higher than the shaded areas. So essentially, if you were to stand out in that field, you could see and potentially shoot this transformer. You can also see that these trees are all highlighted in red. So if somebody were to obviously climb up into those trees and hang out, then you can see into this yard pretty unobstructed. So in this video, this workshop, the security experts were taking a look at different avenues. They're going to take a look at some different perspectives. And what we had done there, and I'm just going to pause momentarily because it happens really, really quick. We had digitally created a wall around the perimeter of this portion of the site. We're sizing it between 12 and 15 feet because the experts in this particular case didn't know if 12 feet was going to be sufficient or if 15 feet was going to be sufficient to protect that asset. So we're able to represent in the software the dimensions of each of these barriers. So here in just a second, we're going to resize this wall.
And that's powerful to be able to do this in a meeting, like changing the wall size and the location and the shape and the configuration.
Right.
This is the future of engineering, by the way.
So once again, they're taking a look at how that protects that asset from those areas of concern. A little bit of different perspective here.
I often joke with my teams that what we need to do is develop some sort of video game out of this thing. It's because that's exactly what it is. It's the same technology used for Call of Duty or whatever your kids play. That's what my kids play. So
Yeah.
same exact technology.
So I'm going to pause this here real quick. This barrel represents a 6-foot tall human being. So I'm going to go ahead and play it. What we're going to see is from that perspective of that 6-foot tall person, what it would look like on the outside of the substation. So you can see that you cannot see the transformer with that wall there. So what we're going to do is we're going to resize it really quick here, shrink it down just a little bit, and try and save some additional cost and still make sure it's protected. There we go. Back to our perspective. And yep, you cannot see the asset. And we're going to turn it off, and you can see right through the chain link fence. So one of the things that we were thinking about during this workshop is, well, that's an expensive wall. So if we bring that protection a little closer towards the transformer, what's that going to look like, and can we properly shield it? Now keep in mind, folks, we're able to do this stuff without ever breaking ground.
Yeah. This one I love, because a lot of what we're doing is challenging clearance issues, engineering. So we had engineers on the team, and they were able to verify that what we were doing as part of mitigation was going to work.
Yeah, line clearances. Yep.
Yeah, that team approach when you're doing your ballistics line of sight analysis or your ballistics threat analysis is important.
So you can see over here, let me get my laser pointer. This lane line of approach was still highlighted in red, so that was still vulnerable. So we're adding over another wall over on that corner.
This one was an interesting, because that transformer sits down just a little bit, and those walls being up on the hinge of the slope, top of the slope, really was advantageous for being able to protect that. That was cool.
Yeah. Yeah, so one of the other things that we're going to be doing with this technology is we're going to be building in terrain manipulation. So if we wanted to change the height of a hill, or build a berm, or dig a quote unquote moat to change the terrain and change the lane lines of approach, we're going to be able to do that as well. Another one of the things that we're going to be looking to doing with this tool is adding camera placement. So we can replicate where the camera should be placed, what's going to block their field of view, and the angle of the ability for the camera to see different things. So we can replicate in a 3D model, here's where you could place your cameras, place the least amount of cameras or the most amount of cameras that you think that you need, and what can they see. And just real quick, I'm going to pause this momentarily. We're showing the two different mitigations in this particular study, right? The wall that was going to be, I think if I recall, it was like 1,500 feet from end to end, and as opposed to the other solution closer to the transformer. And this study saved this client anywhere between $10 and $12 million in construction costs. So,
yeah. Although again, that's not the only reason we do these, but
right.
it does help.
Yeah, this is a really great tool to show your work before you do it, right?
Yeah.
We're validating that these mitigations are in fact going to be successful.
Yeah, this is great. And by the way, thanks for helping develop this, Chris.
Yeah, it was fun.
It was good. One of the other things that we can do is, people often ask about vegetation. And well, vegetation can be removed, or what happens if it burns down or a neighbor moves in. So like Chris is talking about, the ability to manipulate terrain is one thing, but the ability to remove trees and do worst case scenario is also important. So we have to take those things into consideration when we're doing these analyses.
Right. So this is another model we did for another client. Once again, we're trying to protect our clients' information. So we're showing different pieces and parts from many different projects and jobs. In this particular case, you can see all this area that's highlighted in yellow was higher elevation terrain than the property itself. What's not highlighted in yellow, if you were to stand or place an object in that area, it would not see the transformer, right? It's lower in elevation. So what we're going to do is we're going to slip over to this next slide with some proposed protections in place. And what they were going to do is they were going to place 360-degree ballistic barrier at a specified elevation around that transformer. And as you can see, we'll bounce between the previous slide real quick. There's all this yellow down here with the protection in place. It did remove a bunch of that line of sight. However, over here to the left and over here to the right, because of the elevation of the terrain, you could still see that asset. And they may not have been able to identify that or realize that without this model. So they ended up going a different route for protections in this particular case because of this.
Yeah.
And once again, typical legacy solutions that we've seen on different projects to protect these transformers and assets. And once again, in the case of terrain where it's a lot of high land, moving that protection as close as you can to the asset as possible to protect it. In some cases, this is the best solution, bolting armor right onto the transformer. And once again, we're product agnostic, but this is a really good solution if you don't have any other options or alternatives.
Yeah, I found this one interesting. The Siemens wraps are interesting. They don't derate or delist the transformer. They still have the same cooling. So it's in cases we've had to use these wraps when nothing else will work. So interesting.
Yep. So real quick, we're going to talk about additional benefits to this this tool and these surveys. So in one particular instance, the client was, like Jason had mentioned, was really concerned about cooling, but they didn't want to go with those bolt-on ballistic items from Siemens. So we came up with this solution. It was a elevated billboard style that's louvered, that was built out of a specific type of metal ferrous material to be ballistic rated. And there's cooling underneath the bottom of these stanchions. There's cooling through these slats. Go to the next slide real quick so you can see a little bit better image up close. And then what we did is we modeled what it would look like around a transformer with some bus work next to it, making sure that our clearances were going to be sufficient.
Yeah, it was cool to see that one specifically was up on almost on a stand. The reason is you didn't need any protection down below, and these panels can be removed so you can get in there. And I thought that was a really innovative solution that they came up with.
Yeah, absolutely. So, you know, just did some cost-based analysis in that previous case where they were going to do a precast concrete wall about 30 feet tall. This is what they were roughly looking at for material cost, was about 1.2 mil. And in our proposed solution, after doing the survey with our engineered mitigations, that was roughly what the cost was coming down to for material costs. So,
yeah, that was an interesting one.
So, Jason.
Yeah, I'll talk a little bit about delivery. You know, what we're delivering to the client. So again, we will deliver like a lot of 2D graphics, a report. You know, a lot of people use this for their R456. Chris, is that right? They're
Yes.
R456. So they use that as part of the R456. But what we are starting to deliver, you can go ahead and play this.
Yeah, it's not playing. It did in our test run, but
that's right. But what I want to talk about is digital twins for a minute. We're looking at delivering digital twins as one of the products, and the reason is that a lot of times these tools that we develop, the mitigation that we develop, is very difficult to explain just in a 2-dimension. So we will develop as a 3D model, so the physical security specialist can show their leadership, they can show their constituents, and they can communicate what some of the challenges are. And by getting this as a true digital twin, it helps them you know, coordinate a lot of the work that's going on to protect that individual site. So in the future, we'll be delivering these things more and more as a digital twin with the mitigation built into there. And the other thing about delivering as a digital twin is that you can take it back out because it's located in the same area, take it back out and you know, put it into your BIM models if that's what you're using, or CAD or whatever you've got. So it becomes the foundation, the framework for a lot of the construction drawings and shop drawings that you're doing in-house. So it's pretty cool. It's really neat where it's going. You go to the next one.
Yeah, sure. So a little bit of recap, right? We talked about why it's useful and why we need it. We talked about how it works, the data gathering of putting it into the game engine technology software, and then the just a couple of the benefits. You know, I just was at a meeting a couple of weeks ago, a conference where some folks are doing this, and every single week they're finding additional usages for this tool. So physical security line of sight study is just one of those. So
I'll just add to the benefits. One of the big ones that I saw, because that was part of the very first one that we did, and we did it this traditional geometric way. It was 3 months by the time we went from the site and evaluating it, coming up with the mitigation, doing the construction drawings, and then writing the report and give it to the client. It was a 3-month process. Our first pilot that we did with Portland General, from creating the model, analyzing the model, and making our recommendations, was 3 weeks. And so this is not just a testament to the ballistic threat analysis tool we've got. This is where the industry's going for digital twins. This is why we're seeing digital twins, game engine technology, reality models become a standard in our industry, because they're going to drive our understanding, our evaluation, our engineering, our design, and our operations and maintenance of facility. And this is no different. So anyway.
Yeah, a lot of utilities are already starting to design their new locations with using the BIM model. So a lot of this data gathering stuff they already have on hand, which significantly reduces the amount of time it takes to put this stuff together for clients. So
yeah, it's pretty cool. All right, I think that's stand for questions. Larry, you got any questions? What do you got? I'm gonna sit here and sip on my coffee.
Well, first of all, thanks, Jason and Chris, for that presentation. Very interesting. It's not the typical innovative technology presentation that we've had before, but it's, as you kind of mentioned, it's a growing issue, right, for the industry. So really appreciate you doing that. Yeah, I've got a few questions, and while I start off with some of those, I just want to mention again to people who are watching, if you have any questions based on the presentation, please go ahead and type them into that question function. I'll be happy to pass them along to Jason and Chris and Margaret and see if they can respond to them. But let me start off with just a couple of them questions that I thought about. One is, so for companies, utilities that are doing ballistic surveys today, if they don't have this tool, how are they doing those surveys in the absence of that?
that's a great question, Larry. It's a combination of trigonometry and best judgment scenarios. Oftentimes, and almost in all cases, you have to go out and do a site survey, and you may have a couple of folks who have military experience like I do, or law enforcement experience, and they walk around the property and take pictures, lots and lots of pictures. And then, you know, they're like I said, using trigonometry. Jason?
Yeah, so I've seen companies do everything from like walking the site, you know, but basically you're walking the site and look at it, potentially millions of points to be able to look at the site from. And they'll take just survey equipment and kind of log where they're at, either with a GPS point, say, okay, it looks like it's visible over here. But that's why it takes so long by the time you walk the site and at the multiple distances that you're worried about. I've also seen utilities try to take more of that 3D geometric approach, and that's just a series of cross sections that you're doing in AutoCAD, and that gets really time consuming. But in some cases, because it is difficult and it's challenging, some utilities, and you know, I think to their credit too, is just taking more of a programmatic approach to this. Say, if it's this level, you know, we feel it has this level of potential threat, then we're going to do this standard physical security package. If it's an elevated one, we're going to do this standard physical security package. So it's really all over the board. We haven't really seen a tool like this used before in our industry yet. So yeah,
I was just going to say, it sounds like that approach is not just potentially more time consuming, as a result, possibly then more expensive. And then you also kind of wonder if you having to rely on just kind of hoping you hit all the spots by doing a walk around, maybe even potentially more error prone.
Yeah, definitely. The accuracy one is a big one for us. You know, a lot of times the data that you get from publicly available source information is like 1 foot per pixel resolution, and a lot of times you're using 2 foot, 3 foot contours. And because you're not getting accurate terrain representations with just publicly sourced information, you can get some erroneous results. You may think you're protected and you're not. So that's why we spend a good, third of our time collecting that digital twin, making sure it's accurate, because that right there is the foundation for everything that we do. And that's another thing about these type of tools, is that they're as accurate as the information that you can collect and as accurate as the BIM model you can produce. So that's important.
So another question I had was, so you really you focused on the one use for this tool around physical security. Are there other uses that you could potentially have for this technology, or is this pretty much it?
There's a lot. Okay, so I'm going to put my visual analyst hat on here just for a minute, right? So think about when you're in, like you're trying to communicate to the public what a new transmission line might look like, or what a new substation might look like. A lot of times the public gets involved into maybe having a little bit of input on where it's located, just a little bit. So we've actually used a tool variation with this during a corridor, or in a corridor that was adjacent to some residences, where we were sliding the tool, the transmission lines, virtual transmission lines in real time, to try to best position it behind homes and structures and other things and trees, to where it would reduce their overall visual impacts. So definitely in visual analysis. But number two, if you think about national security, nuclear facilities, generation facilities, my first exposure to this tool was back in 2003, where I was doing work for Langley Air Force Base. And we were doing the F-22 bed down project with Langley Air Force Base. And we had to develop a digital twin to see if anyone offside the base could see into the base. And we were kind of mimicking the F-22 going from hangar to hangar, and we're using the same technology. So there's a lot of applications. And then you just think about military. Landing zone analysis, military situation, forward control analysis. There's a lot of tools and technology that could be built around that.
And Larry, I'll say I've known Jason for 10 years. Give him 5 minutes and he'll come up with 5 more uses.
Oh, I got more. You want to go into cell phone tower location analysis? You want to go into where to put my Starlink? I could probably tell you that too, Larry.
You're only limited by your imagination, I gather. That's pretty much it.
That's right.
Yeah. So, and then one thing I also want to follow up with you on, Jason, because you touched on this, but I wasn't entirely sure whether it was 3 months, 3 weeks. How long does it take to do one of these surveys with the application? Does it matter? I wasn't sure. I thought I heard maybe 3 months. I wasn't sure if I heard 3 weeks or whether it was something else.
No, the old way we used to do it was 3 months, because we didn't have the ability to capture it the way we do today with drones. So here's how it breaks down. It takes about a week and a half to do the data capture. That's where we're at today. And sometimes you walk the site with LiDAR, sometimes you fly the site with a drone. Sometimes it depends. Sometimes you can, fly the site with either LiDAR or drone outside the substation. That's about a week and a half, short, as short as a week. But the rest of the part goes quick. You could do these workshops that we were showing you here a little bit ago. Those you can do one day to figure out what your critical assets are, get an understanding of the issues you're facing, and then the workshop on the next day for 2 or 3 hours, and you've got your basic mitigation done. And then from there, it's really the deliverable is 2D graphics, or in some cases helping the utilities develop their R456, and doing their audit. And in some cases, it's doing more of a report, which is like 20, 30 pages long, of our recommendations, and baking in some of our recommendations for construction. Is that right, Chris?
Yeah. So Larry, a lot of it has to do with how much data the client or the customer already has on their property, right? So the more data that they have, if they already have a BIM model or a 3D model, then that really helps speed up the process of putting that information into the game engine software. In one particular case, from start to finish, we were able to get everything done for the client in 4 weeks. That was a very accelerated timeline. They had some very, very tight constraints around needing this information, but we were able to accomplish that for them. So don't expect 4 weeks in every single specific case, but it can be done. So.
Yeah. Yeah, it's all about that data.
Yep.
So,
Great. Chris, I wanted to go back and ask you, going back to your early portion of the presentation where you were talking about some of the lead up to this type of technology and the need for it and the incidents that have been occurring and occurring at a higher pace in more recent years. I'm just curious, is there any trend or pattern to those increases of incidents in recent years as to whether the attacks are more in the category of kind of, I'll just call it random mischief kind of thing, a guy out there maybe had too many beers and playing target practice, versus something that's more nefarious, you know, like a more orchestrated, targeted effort that could have much greater impact. Is there any pattern to any of that, or is it
No,
not sure?
it's kind of all over the board. I mean, really, we go back to that 2013 incident in California. Before that, shooting up of transformers was never heard of, right? It didn't occur to people that it could create damage and cause an outage for whatever reason. So for the longest time, just a regular chain link around the property has been sufficient. And really what we're seeing now is that keeps the honest people honest. But as soon as that one occurrence happened, now we're starting to see all these copycats, like I said, from some extremists from both ends of the scale, anti-tech folks. There's a faction out there of Ted Kaczynski supporters after he passed away that are anti-tech folks. So yeah, a lot of variation, but it's happening, like I said. So.
I guess, and another question I had, also kind of going back to some of the examples you illustrated. I think it was the Maryland example where it sounded like there was, you know, some potentially really broader impact, but the actual targets were maybe lower voltage level, or I don't know if it was distribution level infrastructure or not. It kind of raised a question for me, for this technology or for some of the issues you're talking about generally. What are some of the differences between using this technology for distribution versus transmission infrastructure? Are there any significant differences in the way you have to approach that?
Well, yeah. So when you're talking about transmission facilities, you're usually dealing with, you know, a higher level of NERC CIP standards involved in that process, whether it be CIP 006 or CIP 014, just to throw out a few. But when you start talking about distribution locations, from the NERC standpoint, those are lower down from a cascading outage standpoint. And so that's one of the reasons why April of 2023, when FERC issued a directive to NERC to take a look at some of those standards, they came back with, well, the way that they're written right now protects us from that transmission cascading event. In this particular case, those distribution locations could still be very, very important to the utility owners, right? Like I said, they could support a hospital, they can support, you know, some of their biggest paying ratepayers out there, and they still have an interest to protect those locations. And so we provide this as an option for them to validate what they have in place or find out what they might want to do. Is it actually going to be effective?
yeah, but the
Great.
process is still the same, Larry. It's same process to collect the data, same process to drop in the bin information, and then do the analysis. Yep.
All right, great. Well, I didn't know whether you had any final or points or any closing comments or remarks you wanted to make. We're getting close to the top of the hour. I thought I'd just check back before we go ahead and wrap this one up.
I'd say if there's any questions, we put in Margaret's name and email into the last slide here. So Margaret, I'll let you take the point on if there's any other questions for follow-up. So yeah. Other than that, that's it, Larry.
All right, well, great. Well, listen, Chris, Jason, Margaret, thank you very much for putting on this presentation. It's really interesting. Like I said, a little bit different take on a technology from some of what we've been seeing before, and really appreciate that. Thanks everybody for joining us today. We're going to continue this series into next month, and we have the next in our lineup is Continuum Industries. And they're going to talk a little bit about using AI for helping to site energy infrastructure. So I think it'll be also a little bit of a different take on some of what we've been learning before. So that'll be on April 23rd at 2 o'clock. We'll be putting out more information, particularly through social media on that. So with that, we'll go ahead and wrap this one up. Chris, Jason, and Margaret, thank you very much. Really appreciate you doing this. And we'll see everybody in about a month.
Thank you. Thank you, Larry.
Thank you. Thanks,
Thank you,
Larry.
Larry.
All right, bye now.
Bye-bye.